Alright, this video is going to be on finding the domain of a function. Sometimes it's easier just to figure out what can the domain not equal, what can an x value not equal, since the domain is the set of all x values. When you're given a function such as f of x equals x squared plus 2, when you're asked for the domain of that, one of the things to think about is what can x not equal? And what I mean by that is if I were to plug a number in for x and then square it, would it break any mathematical rules? And the answer to that is no, because if I were to plug in a negative number, like say negative 2, I'd square it and get 4, and then I would get plus 2, so it's 6. So f of negative 2 is 6, and that works. If you plugged in 0, you could square 0. If you plug in a positive number, you would get it. Fractions and decimals, you can square those too. So the domain here would be all real numbers, and we can write it that way, or you can write it as negative infinity to infinity. So that'd be one way of thinking about the domain. The problem comes in when we get a little bit more involved with, say, problems like in this example, when we have a square root, like f of x equals the square root of x plus 1. And then, say, another example where we run into trouble would be something like f of x equals 2 over x squared minus 4. Okay, so in both of these cases, we have the potential for bad things to happen. In the first one, remember, you can't square root a negative. So if you square root a negative number, you get an imaginary number, like the square root of negative 1 is I. So we wouldn't want underneath the radical, we wouldn't want a negative number to occur. So when you think about what can x not equal, well, we don't want x to be something that would make a negative. It allows us to then think in the positive light and say, what do we want x to equal? Well, we want x to be something that would make x plus 1 greater than or equal to 0. Because if we can get the stuff underneath the radical to be positive, then we won't break any rules. So we solve a linear inequality just by normal ways, subtract 1, and then x would be greater than or equal to 1. So our domain is this. Our domain is that we want all the x values to be greater than or equal to 1. If your teacher would like you to write it in an interval, like I would put a 1 with a bracket and then towards positive infinity. That would be my set. Okay? In this one over here, in the second example, remember there's a rule that you can't divide by 0. So we can't have 0 on the bottom. So when you're thinking about what it can't be, x squared minus 4 cannot equal 0. If it does equal 0, we'll be in trouble. So when would x squared minus 4 equal 0? Well, let's factor this. It'd be x plus 2 and x minus 2. And so when would this equal 0? Well, when x plus 2 equals 0. And it would equal 0 when x minus 2 equals 0. So x would equal negative 2 and x would equal 2. And so what we're saying here is you actually cannot equal 2 and negative 2. So your domain, an easy way to say the domain in this problem is to say what x can't be, since it's two specific numbers. We would just say x can't be plus or minus 2. And basically by saying what it can't equal, we're saying what it can equal. It can equal everything but plus or minus 2. Let's look at one last example that could be a little crazy, like something from the homework that we've looked at. F of x is, let's go with the square root of x squared minus 4x. And then let's go with over 2x. So now we've got two parts to this problem we got to look at. Got to look at when you'll have a positive underneath the radical, and you got to figure out when will 2x equals 0, because if you can figure that out, then you don't want the bottom to be 0. So this answer in that case would be that x can't equal 0. 2x would equal 0 when x is 0. So we don't want x to be 0. We also don't want x squared minus 4x to be less than 0. So we want it to be greater than 0. We don't want it to equal 0 because we've already said that x can't equal 0. So we just want it greater than 0. And now it's a quadratic inequality. And so to do a quadratic inequality, we're going to factor x times x minus 4. And that needs to be greater than 0. And then we need to put these critical values, which are x equals 0 and x equals 4. We need to put those on a number line, so 0 and 4. And we want to find what intervals would work. So the intervals can be tested by x equals -1, x equals 1, and x equals 5. What we're going to do is we're going to plug those in and see if they make the inequality true. So when I plug in -1, I'd get -1 times -5, which would be a +5, so that would work. Check. Yes, good. And then when I plug in 1, I would get 1 times -3, which is -3. That's bad. And then when I plug in 5, I would get 5 times 1, which is +5, so that's good too. So I don't want x to equal 0. We have that over here. But I do want x to be -infinity. It can be negative all the way up to 0, but not equal it, with the union of, it can be 4, but it can't. Could it equal 4? Yeah, I think we're okay with saying it could equal 4, right? It could equal 4 because since it can equal 4, 4 when I plug it in wouldn't make the bottom 0, but it would make the top 0, and that's okay. So bracket, and then on to infinity. And so that's kind of a tricky one, but that would be the way to do the domain for a problem like that. Okay? All right, so that's how you do the domain of a function. Have a great day.